So in the last video we have seen that in functions the mappings are either 1 1 or many 1. So if some of the elements of the domain, if they get uniquely mapped to one element, one common element, then it's a many 1. And if all the elements of domain are mapped to different elements of codomain, then it's 1 1. Now let's look further into it. Let's say you have a function from A to B. Okay, this is 1 1 function. Okay, now if it is 1 1, it means every element of A is mapped to different elements of B. Okay, so if it is 1 1, let's say the number of elements in A is equal to n. Then what should be the number of elements in B? Because every element of A is mapped to a different element of B. If this is your A1 and this is your A2, A1 is not equal to A2 means that f of A1 is not equal to f of A2, right? If A1 is mapped to, let's say, B1, now B1 cannot have any pre-image other than A1. In your 1 1, from the B's perspective, every element of B will have a unique pre-image if it has a pre-image. Okay, in 1 1, any element of B may or may not have a pre-image. If it has a pre-image, then it's a unique one. So A2 will be mapped to some other element, but not B1, B2. So in this manner, the number of elements in B has to be greater than or equal to A. Means for sure, what is the minimum number of elements in B? If every element is mapped to some other element, every element of A must have an image because A is the domain. And for a function, all the elements of domain have a unique image. So it means the number of elements in B, minimum number of elements in B has to be equal to the number of elements in A. So number of elements in B is greater than equal to number of elements in A, because there might be some more elements, B6, let's say B7, that has no pre-image in A. This is your 1 1. So in case of 1 1, if number of elements of A is n, the number of elements in B is greater than equal to n. Okay, so basically the thing is, in 1 1, number of elements in your codomain is greater than equal to number of elements in your A. Now when this is equal, because it is greater than equal to, so you can divide it, you can take it as two cases. When number of elements in B is equal to number of elements in A, or when number of elements in B is greater than number of elements in A. Okay, so when number of elements in B is greater than number of elements in A, what does it mean? It means there are some elements that don't have any pre-image. It means that your range is a subset of your codomain, proper subset. It means it is into function. It means 1 1 and into. Now if number of elements in B is equal to number of elements in A, it means that all of those elements have a pre-image, and so range is equal to codomain, and so in this case it is 1 1 and onto. Look at this. A1 is not equal to A2, then f of A1 is not equal to f of A2. This is you can take it as a formal definition for 1 1 function, that when two different elements of A, they have two different image, their images are also different. Now if a function is given to you, how do you find out if it's 1 1 or not? Okay, if a function is given to you, how do you find out if it's a 1 1 or not? In the last video we have seen that if the graph of a function is given or the curve of the function is given, we can easily find out if it is a one function or if it is many one function. Now let's say expression of a function is given. Curve is not given, just the expression of a function is given. Then how can you find out if it is 1 1 or not? It's very simple. You make use of this fact that let's say f of x is equal to 2x. So here f is from a to b. Let's take an example where g is from r to r. So we have seen in the last video that how it is a function and it is a 1 1 function. Now if this just the expression is given and curve is not given, just from the expression itself you can find it out, making use of this fact that if you assume f of a1 and f of a2 where a1 is not equal to a2, then both of them have to come different or unequal. Now what you do, you make it equal. You make f of a1 and f of a2 to be equal. So when you make f of a1 or f of a2, so I am erasing this now, 1 1 or not, that is what you have to check. So what you do, you know that in a 1 1 function, a1 is not equal to a2, or simply say a not equal to b. Okay, if a is not equal to b and a and b belongs to the domain, then g of a will be not equal to g of b. This will be the case if it is 1 1. Now if you want to prove it, then what you do is you will find GA, you will find GB, and you will equate them. Okay, just do GA equals to GB, and if ultimately solving this gives you A is equal to B, it means what? It means that the expressions are, if the expressions are equal, means the input you gave was equal. Okay, otherwise the two will never be equal. This is what will prove that this function is 1 1. So if you do 2a, g of a is 2a and g of b is 2b. So this gives a is equal to b. It means that this was 1 1. I am taking any arbitrary element a and b. Okay, that's it. This is how you can find if a function is 1 1 or not if the expression of the function is given. So what we can say about 1 1, number one is that if function g is 1 1 means that a not equal to b, then f of a is not equal to f of b. So okay, this time I'm taking g of x, so let's do g of a. Means my function name is g, rule name is g. So if a is not equal to b, then g of a is not equal to g of b. Means if it is known that your g function is 1 1, if it is known that g is 1 1, then if a is not equal to b, then g of a is not equal to g of b. If g of a is equal to g of b, then what you can say? Then it means a is equal to b. I wanted to complete the mapping in this video alone, but right now biryani.